Welcome back to the third part of field sampling and testing for bituminous construction. In this part of the course, we'll cover field testing of aggregates, including tests for gradation, sand equivalent, crushed faces, and flakiness index. Gradation testing is done to determine the proportions of different sizes of particles in the aggregates. First, you prepare the sample by drying it to a constant weight, splitting it to obtain the appropriate sample size, weighing the split sample, and recording this total weight. Then, you test the coarse aggregate by installing the appropriate sieves and pan in the shaker, pouring the entire sample over the top sieve, shaking the sieves so that the aggregates flow through, weighing the portion retained on each sieve, and recording each of these weights. Next, you prepare the fine aggregates for sieving by weighing all the fines that pass the coarse sieving, splitting them to a split sample size of about 500 grams, drying them to a constant weight, and recording this weight, washing the fine aggregate to remove the minus 200 material, drying the washed fines to a constant weight, and recording this as the washed weight. Then you test the fine aggregates by setting up the appropriate size sieves and pan, placing the sample in the top sieve, shaking the sieves so that the material can pass through, transferring the portion retained on each sieve to a tiered pan, weighing each retained portion of fine aggregates, and recording each of these weights. There's more to be done in terms of calculating the test results, but these steps will be covered later in your workbook. The sand equivalent test is used to determine the proportion of fine dust or clay in the aggregates. Excessive amounts of these fines can reduce the cohesion in a bituminous mix. To conduct the sand equivalent test, you'll need an appropriate size sieve, 3 tin measuring cups with each having a 3-ounce capacity, 3 plastic cylinders with stoppers, a weighted foot assembly for the sand reading, some working calcium chloride solution, and a clock or timer. First, prepare the sample by running it through the sieve. The material that passes the sieve is used in the sand equivalent test. Then split this material down to a sample size that would fill 4 3-ounce tins so that you are sure to have enough. Fill all 3 cups, seeing that the material is fully settled in each cup, and striking off the excess to be sure you have exactly 3 ounces in each cup. Place the working calcium chloride solution in the plastic cylinders. Then place one of the 3-ounce samples into the first of the plastic cylinders. Tap on the cylinder to slightly agitate the material. You can then start testing each of the other 2 samples while you wait 10 minutes to allow the first sample to soak. After 10 minutes is passed for the sample, close the cylinder with its stopper, pick it up, and turn it over to loosen the material, and shake the cylinder to help dissolve the material. Then set the cylinder down and remove the stopper. If you're using a mechanical shaker, you can start shaking the second cylinder so that it is shaking while you irrigate the first cylinder. This irrigation is needed to help suspend the fines in the solution so that it is separate from the coarser sand. After irrigating the first sample, continue the shaking and irrigation process for the other 2 samples, while you wait 20 minutes for the sand to settle. After 20 minutes, read and record the clay reading at the top of the clay suspension. Then insert the weighted foot indicator so you can read and record the sand reading. Finally, use the clay and sand readings for each sample to calculate its sand equivalent and the average sand equivalent for all 3 samples. The crushed faces test is used to determine the shape of the aggregate particles in terms of the percentage of particles that have been mechanically crushed. A mechanically crushed particle has an irregular shape with sharp edges that help it interlock with other particles. Relatively smooth particles with rounded edges are less desirable because they do not interlock with each other. You'll need the same equipment used in gradation testing for coarse aggregate, but with the addition of a number 8 sieve, a clean, flat surface, and a magnifying glass. To prepare the sample, sieve it as you would for the coarse aggregate in gradation testing, but include the number 8 sieve. Then recombine the appropriate portions of the sample. For mineral aggregates for mix, all the +8 material is used. For cover material, use only the portion between the 3/8 inch and number 8 sieves. Split the sample down to about 300 grams for mineral aggregates or about 100 grams for cover material. Weigh the split sample and record this weight as the total weight. Then spread the test samples out on a clean, flat surface and start examining each particle for crushed faces. Separate all the particles with at least one crushed face from the particles that have no crushed faces. Here's an example of a particle with crushed faces. The sharp edges indicate that it has been mechanically crushed. Here's an example of a particle without any crushed faces. The worn and rounded edges indicate that it was not mechanically crushed. When all the particles have been examined and separated into the two groups, transfer the crushed face particles back into the tared weighing pan, weigh the crushed face portion, record its weight, and calculate the percentage of the crushed face portion in relation to the total weight of the sample. The flakiness index test is used to determine the shape of the particles in terms of the percentage that are relatively flat. Flat or flaky particles, as shown at right, are less desirable because they tend to shift against each other or break down under a load. For the flakiness index test, standard gradation sieves and a balance scale are needed, but the key equipment for the test is a series of slotted sieves. The sample is first screened through a specified series of standard sieves. Each retained portion is then weighed, and the weight is recorded. Next, each retained portion is tested particle by particle by trying to pass each particle through the appropriate slotted sieve. Each portion that passes through its respective slotted sieve is then weighed, and the weight is recorded. From this information, you can calculate the percentage of each portion passing its slotted sieve and the flakiness index for the total sample. In this part of the course, we've gone through the procedures for